Greetings to viewers. I, Kwanit Gupta, finally an undergraduate student at IIT Jodhpur, is going to present the computer vision project on the topic Comparative Analysis on Face Identification Based Modeling. In this, I focused on following the progression of implementing different solution paradigms, including traditional ML methods, state of the art convolutional neural networks, and their improvements through face recognition based custom loss functions. So, facial recognition is crucial in day to day applications, including security surveillance, social networking, etc. It is indeed an umbrella of subtasks like face detection, alignment, identification, etc. And over the years, solutions changed significantly, ranging from eigenfaces algorithm via PCA to handcrafted features-based ML paradigm and nowadays sophisticated deep learning architectures. But the main problems for this include hugely varied training datasets, which indeed are not universally able to assist in an optimized system, and fluctuations via occlusion, lighting conditions, etc. So, in order to understand the experimentations and the methodologies behind the same, I picked some ML models of different kinds, including tree based models, which generally utilize Gini entropy on assigning the decision on nodes and leaves, like decision trees and random forests do. Some aggregative models, which rely on major voting schema and weak cascading distributions of base estimators, like bagging classifier and Adabus classifiers do. And at the end, support vector machine, which takes help of margin samples near the decision boundary. And when we are coming to convolutional neural networks, I picked three resource constrained architectures like SqueezeNet, ShuffleNet, MobileNet, which utilize unique components like expand squeeze channels, depth-wise separable convolutions, and two-script connections based models like ResNets and DenseNets. For loss variants, I utilized multi-class cross entropy loss, cos phase, and arc phase, which use a cosine similarity in such a way that the features can become discriminative, and they will be highly discriminative on the basis of the class distribution, even though the class distribution is balanced or unbalanced. Regarding the experimental details, I took two different datasets, naming labeled faces in the wild and a subset of IMFDB, which stands for Indian Movie Face Database, proposed by IIIT Hyderabad. I utilized Google Collaborative Services to run my experimentations, especially with NVIDIA Tesla K80 GPU. The GPU has 2496 CUDA cores, a base clock of 562 MHz, and 12 GB of GDDR5 RAM. So, as a matter of evaluation schemes, I saw that multi-class ROC AUC curve will help to observe the inclination of models with respect to certain classes. But also, we don't have to forget that we have class-wise accuracies, precision, recall, and support in order to justify that why a certain model is underperforming or why a certain model is overperforming. So, the rest of the things are mentioned in the report itself, including the accuracies, various accuracies like macro accuracies and weighted accuracies, and some of these particular multi-class ROC curves, especially focused on the subset of IMFDB dataset with the loss function varieties. Now, let's go to the coding part, the notebook which I have prepared. So here, I have prepared up the notebook and it's been shared on the report itself. So here, I have attached up the Google Drive. I installed PyTorch Lightning on the environment. I imported out some of the libraries, sklearn based libraries, Torch Vision based libraries, and even PyTorch Lightning as well. I followed the functional paradigm for transforming, for feature detection, handcrafted features, for returning of the model, for accuracy and multiple matrix that we have to print. I also followed the OOPS paradigm for choosing up the model. It totally depends upon the consumer that which type of model he or she wants to use alongside the loss type, which is like cross entropy, arc phase, or cos phase. Even I have included adaptive phase loss, but due to time constraints, I haven't been able to produce the results. So here's like the traditional machine learning approaches where I have loaded up the LFW dataset, and these are the different code snippets or rather code blocks where I have used some feature descriptors like SIFT or Akaze alongside the models like support vector machine and etc., which we have discussed earlier on, and especially on IMFDB. I have utilized up some of the code blocks for binary cross entropy loss and other losses. And for other losses, I picked up three best performing models like ShuffleNet, ResNet, and DenseNet. So here are the code blocks accordingly. And these are the particular progressions of the code that can occur for a certain model, like including up inserting up the directory, setting the maximum epochs to 15, and then producing up these particular graphs, the class-wise metrics like precision recall, F1 score, and support, class-wise accuracies as well, the overall accuracies as well. So that's kind of the stuff. And I have attached up the collaboratory notebook, the report as well in the repository. Thank you once again.